بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will talk about numerical sequences. Specifically, we will see what is the meaning of a bounded sequence. Property 2. Let UN be a convergent sequence that is defined recursively for every n by its first term u0, and the relation un plus 1 is f of un. So here we know un plus 1 in terms of un. Remember, f is a function. Well, if f is continuous, then the limit of the sequence would be a root of the equation L equals f of L. In other words, if un is convergent, this means that its limit exists. Now, how do we find this limit if the sequence is defined recursively? In fact, this limit would be nothing but a root of the equation L equals f of L, where f is the function that defines the relation between un plus 1 and un. Let's see an example. Un is a sequence defined as u0 is negative half and un plus 1 is un into un plus 1. So this is a recursive sequence. In fact, this is the sequence that was given in example 2. Well, prove by mathematical induction that un is bounded between negative 1 and 0. This is done before in example 2. Prove without using mathematical induction that un is an increasing sequence. This is also done before in example 2. And deduce that the sequence is convergent. And we said before that this is an increasing sequence which is bounded from above, so it's convergent. Also done before. Well, the question is, find the limit of un. Being a convergent sequence means that its limit exists. How do we find this limit? Let's see. So, in this case, we know that un is defined recursively. We know un plus 1 in terms of un, and we have an initial term here. And we know that un is convergent, is proved in part 3. And we do perform a function f that shows the relation between un plus 1 and un. We write the function as un plus 1 equals f of un. So what is f of x in this case? If this is f of x, it would be x into x plus 1. And this is continuous for x belongs to 0 plus infinity. Remember here we took 0 plus infinity because n belongs to n. Thus, the limit of un, the quantity that we are searching for, would be nothing but a root of the equation L equals f of L. This is f of L, and this is L. So if we write this equation, we can say that L equals f of L, which is L into L plus 1. If we expand, we get L equals L squared plus L, or L equals 0. Thus, the limit of un as n tends to plus infinity is 0. So let me re-explain it very quickly. un is defined recursively. It is convergent. We perform a function f that shows the relation between un plus 1 and un. And from this function, we're going to find L, which is the limit of un. How do we find it? We just write L equals f of L. F of L is L into L plus 1, and this is equal to L. We solve this equation using previous methods. We get L equals 0, so this would be the limit. Remember the theorems of monotonic sequences. Let's see application 3. un is a sequence defined as u0 is half, and un plus 1 is this quantity for every n. We do know that un is positive. The question is to prove by mathematical induction that un is less than 3. Try to do it alone. Remember, you have to do it inductively. So the question is to prove that un is less than 3 for every n. We verify it for n equals 0. Is u0 less than 3? This is true. We suppose that it's true for n equals k. So we know that uk is less than 3. We prove it for n equals k plus 1. So is uk plus 1 less than 3? This is the question. We see uk plus 1 minus 3 is this quantity minus 3, which is this quantity. 5 into uk minus 3 over uk plus 6. Now, is this negative or positive? Let's see. We know that uk is less than 3 from here, so this means that uk minus 3 is negative, so the numerator in this case is negative. And we know that uk is positive, and if uk is positive, this means that uk plus 6 is positive. So the numerator is negative, the denominator is positive. This means that the whole ratio is negative, and uk plus 1 is less than 3. And finally, we can say that un is less than 3. So till now, remember, un is greater than 0, so it's bounded from below by 0, and it's smaller than 3, so it's bounded from above by 3. Let's see. Prove that the sequence un is increasing. Try to do it alone also. Well, un plus 1 minus un is this quantity minus un, which is this quantity. And if we factorize, we get minus into un plus 1 into un minus 3 over un plus 6. If we take each factor alone and we check up whether it's positive or negative, we know that un minus 3 is negative. We know that un plus 1 is positive and un plus 6 is positive because un itself is positive from here. So we have negative, positive, positive, and a minus sign. So the whole quotient is greater than or equal to 0, and we can say that un is increasing. Now part 3, prove that the sequence un is convergent. Try to do it alone. Remember to use the theorems of monotonic sequences. Well, un is convergent, being an increasing sequence from here that is bounded from above by 3 from here. Okay, the last part. Find the limit of the sequence un. Well, this is a sequence that is defined recursively, so we have to remember the property. Try to do it alone. Let's see. What do we have in this case? un is defined recursively. un is convergent from part 3. We perform the function un plus 1 is f of un, or f of x is 8x plus 3 over x plus 6. So here we replace each un by x, and we replace un plus 1 by f of x. And this is also continuous for x belongs to 0 plus infinity. Thus, the limit L that we are searching for the limit, is a root of the equation L equals f of L. So we write L equals this quantity. We get this second degree equation. L equals negative 1. This is rejected since u0 is half. u0 is half, and this is an increasing sequence. So it becomes larger and larger, and it cannot be negative. And L equals 3, and this is accepted. So the limit that we are searching for is nothing but 3. Okay, now Rami, Amir, Rima, or Mira. We have the 4 students at the same time. un is a sequence defined for all n as un is between 0 and 2, and un is a decreasing sequence. We need to prove that the sequence un is convergent. Let's see. Rami, un is convergent because it's a decreasing sequence. So Rami believes being a decreasing sequence means that this is convergent. Amir, un is convergent because it's a bounded sequence. So for Amir, being a bounded sequence means that it's convergent. Rima, un is converging, being a decreasing sequence that is bounded from above by 2. And finally, Mira, un is convergent, being a decreasing sequence that is bounded from below by 0. So which answer is correct and which answer is not? I think Mira's answer is correct because she is applying the theorems of monotonic sequences. When it's decreasing, we have to see whether it's bounded from below or not. So Mira's answer is correct, and the other 3 answers are not. Thank you.